Hello, this is Mr. Carlin. Let's talk about lesson 10-6, Outliers, on page 575. Make sure you got a pencil and a highlighter. I'm going to be highlighting some vocab in this one. Alright, so let's look at the I can statement. It says, I can understand how an outlier affect the measure of center and determine which measure of center is most appropriate to use when describing a data set that does or does not contain an outlier. Now remember, measure of center, that's mean, median, or mode. Okay? And what we're going to be talking about today is outliers and what measure of center, mean, median, or mode, that really affects. Okay, so let's talk about what an outlier is. An outlier is a data value that is very far away from the other data values. It's something that stands out. If you're to say you're an outlier, you stand out. Okay? Alright, it can be much greater in value or it can be much less than. Okay, it's a number that doesn't really fit in. How do you know if either of the extreme values, okay, in this data set, okay, how do we know if 225 and 780 are considered outliers? Well, first we have to put them in order from least to greatest, and that's what it looks like. Is it done that? Yes, it's got them in order from least to greatest. So we're looking at these two values, 780 and 225, and we're trying to determine which one is an outlier, or even if they are considered to be outliers. An outlier is defined as the value that lies more than 1.5 times the interquartile range above Q3 or Q1, or below Q1. Okay, so remember finding IQR. Q1, that's the middle of the lower half. Q3 is the middle of the upper half. In order to find those, you have to first find the median, so we find the middle, and then we find the middle of the upper half and the middle of the lower half. Okay? And for a number to be considered an outlier, it has to be more than 1.5 times the interquartile range. Okay? Above either Q3 or Q1. Alright, so then we have to find the interquartile range of our data. Okay, I'm going to zoom this in just a little bit so you can see what we're doing here. Okay, our interquartile range is the distance from Q1 to Q3. So we have, for Q3, we're going to take Q3 minus Q1, so 475 minus 300, okay, or we have an IQR of 175. Okay, so to find the upper limit, okay, to know what is within the range of what's considered an outlier, 1.5 times, we're going to look at taking the upper limit, taking the Q3 plus 1.5 times the IQR. So we have our Q3, and we're going to add that to 1.5 times 175. Because that's our IQR. So we plug all that in, we do all that. So we end up with, for this one, 737.5. The lower limit, okay, so we're going to take Q1, which is 300, and we're going to subtract that, because it's lower, we're going to subtract, okay? And it's going to be 1.5 times 175, because that's our IQR. That's where that 175 comes from. And then we do 300 minus what that is, and we end up with 37. Okay, so what does that mean? Any data values that are greater than 737 or less than 37.5 are outliers. So numbers that are either greater than this or less than this in this data set are considered an outlier. Well, in that data set, is there a number that is greater than 737? Yeah, there is. 780 is going to be our outlier because the data does not contain any values that are less than 300 or 37.5. So this number is not less than 37.5. So 780 is the outlier. It is over what it should be. The limit is on that. A limit can't go over. Okay. Now the box plot represents the data. Outliers are indicated with an asterisk. Okay, we usually indicate outliers with a star. Okay, so if we don't use that 780, our box plot ends up looking like this. Okay, so if the outlier was removed from the data set, would the median change, or would it still be this? Why or why not? Well, technically, looking at where, if we take that outlier out, looking at where the median is here, it looks like our median's still going to be at about 370 or 387. So our outlier doesn't change the median. Okay, so outliers don't really have a huge effect on the median, but they do affect other things like mode and mean. So let's look at that. All right, first let's talk about identifying outliers. It says the ages in years. We're going to do this example, okay, on the next page. The ages in years of candidates in an election are 55, 49, 48, 57, 23, 67, and 72. We're going to identify any outliers that we might have in this data set. So we're first going to find the quartiles and the interquartile range. Now, before we do all of this, when you look at these numbers, is there one that maybe doesn't fit in? If we were to take a guess, if I was to guess, I would definitely say 23 does not fit in. Okay, so that could be considered an outlier, but let's check to make sure. Remember, we have to find our limits. So we're going to find the quartiles and the interquartile range. We're going to list the data values from least to greatest. Okay, so 23 being the smallest. So it was 23, 48, 49, is it 55 next? Then 57, then 63, then 72. Okay. Then we're going to find the quartiles and the interquartile range. Okay. So we need to identify the median. Remember, median is middle. So we go to the middle. Looks like that's going to be 55. 55 because I got 3 this way and 3 this way. Okay. Then our Q1 is the middle of the lower half. So the lower half of data is 23, 48, 49. What's in the middle? It's 48. So our Q1 is 48. Then Q3 is going to be what? Middle of the upper half, so 63. And then we find our IQR by subtracting 63 minus 48. We end up with 15. Okay. Now we have to find our limits. So we're going to do Q3. If we're doing upper, we're adding. So we're going to do Q3 plus 1.5 times the IQR. So our Q3 was 67 plus 1.5 times, so that's going to be 63, and if you do 1.5 times 15, because 15 is our IQR, that ends up being 22.5. Add those two together, and it ends up being 85.5. Okay, so our upper limit is 85.5. Anything over that, okay, is considered an outlier. Well, if we look, our highest number is 72, so it looks like our outlier is not going to be this biggest number. Now let's check our lower limit. Lower, we're going to be subtracting. Okay, so we're going to take Q1. What was Q1? It was 48. And we're going to subtract that from 1.5 times 15. So 48 minus 1.5 times 15. That's again 22.5. Okay. So we subtract that. And we end up getting 25.5. So our lower limit is anything under that is considered an outlier? Well, just like when we were guessing earlier, okay, 23 doesn't fit in. 23 is also a couple lower than that. So our outlier has to be 23. Because the data set does not contain any values that are greater than 85.5, the only outlier is 23. All right, I want you to pause the video, do this check question down here at the bottom, come back and check your work. Okay, so let's come back and look at this. We have numbers that are 354, 88, 259, 275, 727, and 1121. We need to identify if there's any outliers. Now, to determine if there are any outliers, we have to find remember, our upper limit and our lower limit. Okay. Now, looking at this, I have a number that is quite a bit smaller than all the others, and another number that's quite a bit bigger. Okay, so we got to decide which one of these, or if there is even an outlier according to our limits. Okay, so remember to do this. We're gonna find the median, Q1, Q3, and IQR. So we got to put them in order from least to greatest. So 88, and then what's the next one? 251. And the next one, 275. Okay, then the next one, 354. Okay, then 727. And then 1121. All right. I'm going to make sure I got the calculator out to do all this correctly here. Let's set it off to the side. Okay, so we find the middle. Okay, did I get all the numbers? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we need to find the middle, starting on the ends. Looks like I have two numbers in the middle. Okay, what do I do if I have two numbers in the middle? I'm going to add them together and divide by 2. Okay, so we're going to do 275 plus, let's see here, there we go, 275 plus, make sure that's on camera, 354, and then divide that by 2. So our median is 314.5. Okay, so now we find the middle of our lower half. Okay, middle of our lower half is going to be 251, so this is Q1. Upper half is here, so this is Q3. And we're going to start out with finding our limits. Now remember, go back to this example. We're going to do Q3 plus 1.5 times the IQR. So we need to find what the IQR is. Remember, this is the median. So we are going to have to do 727 minus 251 to find the IQR range. So we have a range of 476. So our IQR is 476. And we're going to use that. And we're going to do, for our upper, let's just do it over here, 727 plus 1.5 times our IQR of 476. Okay, so I'm going to do that on my calculator. Okay, so my upper limit is 1,441. Do I have anything that goes over that? This one is close, but it doesn't go over that. Okay, so this is not an outlier. So let's do our lower limit. Okay, we're going to do Q1 minus 1.5 times the IQR. So we're going to do 251 minus 1.5 times the IQR of 476. Okay, so we're going to do 476 times 1.5. Okay, and did I do that on lower limit? I don't know if I did that right, to be honest. IQR was this. Yeah, I would do that right. So then I do 251 minus 4. 251. Wow, let's start over here. 1.5. Actually, probably just do it like this. Smart calculator will let me do that? No. Alright. So 1.5 times 476, that's 714. And we're doing 251 minus 714. Well, it seems odd because we get a negative number, but we should have no data sets that are our limit, lower limit is this. So this number is bigger than that, so we don't have, there are no outliers in this data set. And those are big numbers to use, okay? But same concept, there's no outliers in this data set, okay? All right, let's move on to talking about the effects of an outlier, okay? We need to describe the effects of outliers. If a data set contains an outlier, the outlier may affect the measures of center and or variation. Suppose you track the daily high temperatures for 1 week and the results are recorded in the table shown. So here's our data, okay, from Sunday to Friday. We have 72, 68, 71, looks like not bad, okay. So suppose the high temperature on Saturday is 42 degrees. Okay, so Saturday's missing on here, and they add that in. (42 degrees). Okay. This temperature is much lower than the other temperatures in the data set. It is also an outlier because 42 is less than the lower limit of the outliers. Now they show us how they got the lower limit. The lower limit is 59, and so since 42 is less than 59, 42 is considered an outlier. Okay? So what does that mean for our data set? What does it affect? Does it affect median? Mode? To see how the outlier affects the measures of center and variation, this is on the next page, we need to calculate the measures of center for both with and without the outlier. So we're going to calculate the measures of center of the outlier. We're going to start with mean. Remember, when you're doing mean, you're going to add them all together, divide by how many numbers you add together to see what your average is or your mean. Okay? So we're going to find the mean with the outlier 42. And we end up with an average of 67.7. All right. MAD, mean absolute deviation. Okay. I need to look at this. Make sure I'm on the right page here. Okay. MAD is a measure of variation. Okay, it's about distances from the average, how far each number is from the average, if you remember in our other lesson. So when we calculate the MAD, and I'm not going to do that in this example, but work it all out because we did that in the last lesson, but when we calculate the MAD, we end up with a variation of 7 4/10. Okay? And then our median, which is our middle, that is 72. That's a measure of center. And then our IQR, that's a range or a variation, is 6. Okay? Now, if we do all that without the outlier, that means we take off the 42. Okay? So here, again, same numbers, but this time, notice we did not use 42. We're going to find the average. Okay? We're going to find the average without the 42, and we end up with an average of 72, or a mean. Excuse me. Then we're going to find the MAD, and I'm not going to work out all the excuse me, all the MAD, but when we work it out, we end up with a MAD of 1 7/10, and then our median stays at 72 again, didn't change really in the median, and then the IQR changed to 3. So what were the measurements that changed? Well, it looks like we went from, when we used the outlier, we had a MAD of 7 4/10, and without the outlier, it changed to 1 7/10. So our MAD changes with an outlier. Our medians didn't change, they stayed the same, so median's not really affected by an outlier. The IQRs, those do get changed, that variation got changed, and then the average got changed also. We went from 72 to 67.5, so mean. So the measures of center that change the most are mean, IQR, and MAD. So let's read this here. It says the median was not affected by the inclusion of the outlier. Without the outlier, the mean, MAD, and IQR all increased in value. With the outlier, the mean is not the best representation of center because most of the values are higher than 67.7. Let me slide this down. There we go. So if we have an outlier, we use either the mean or the median when the data does not contain, or we use either the mean or the median when the data does not contain an outlier. Use only the median when the data does contain an outlier. That is the important part right there of this entire lesson. Is what we're trying to explain is if there is an outlier, describe the data with only the median. If there is not an outlier, use mean or the median. Okay? So while the median might change a little when an outlier is included or removed, it does not change as much as the mean. Use the corresponding measures of variation to describe the spread of the data. If you choose the mean to describe the center, choose the MAD to describe the variation. If you choose the median to describe the center, choose the IQR to describe the variation. Okay. Let's go to example 2, describing the effects of an outlier. The whole point of this lesson is that if there is an outlier, use median. If there is not an outlier, use mean. Okay? And you got to determine if there is an outlier by finding the limits. All right. So let's describe the effects of outliers. This table shows the average lifespan of selected animals. Okay, table with animals. We're going to calculate the mean and median with and without the outlier of 200. Then choose the measure of center that best describes the center. So when you look at this, you don't even have to really calculate it. Your limit, you can see that 200 is well outside of everything else. Okay, it's going to be the outlier no matter what. Okay, we don't even have to find the limits. So we're going to calculate the mean. Remember to do that. We're going to add everything up, and this one is with the outlier. Okay, we are including finding the mean with that outlier. So when we do that, we end up with an average lifespan of 62 1/10 years. Oops, that's supposed to be 1. There we go. Our median, okay, now to find median, we got to put them in order from least to greatest, and it looks like, nope, they didn't do it there, so we're going to have to do it here. Let's see. So it goes 20, then looks like we got 2 30s, then 35, then 50, then 70, and then 200. Man, turtles, they live to be old. Alright. So our median is our middle. Hey, diddle diddle, median in the middle. That's what I always like to say. Alright. So we're going to start by covering up the ends. There we go. 35 is right in the middle. So that's our median. Okay. Then we're going to calculate the mean and the median without the outlier and round to the nearest tenth if necessary. Okay. So notice when they did the mean here, they added everything up, but they left off the 200, and they divided by 6 instead of 7. So when they get that, they end up with an average lifespan of 39 2/10. Okay, now they're going to find the median, or the mean, or median, I'm sorry, that was the mean. So we're going to do 20, 30, 30, 35, 50, 70, and then we don't need the 200. We're leaving that off. Okay, so starting on the ends, cover up. So we got 2 numbers. So it's going to be 30 plus 35 divided by 2. So that is 65 divided by 2. So we end up with an average lifespan of 32 and a half years. Okay. So if we're describing this whole set of data, our best measure of center, okay, let's see, what did we say this was? 32 and a half. Okay, that was our median. So the best measure of center, the blank was most affected by the inclusion of the outlier. Mean without the outlier was 39. With the outlier was 62. So mean changed more when we had the outlier. The median without the outlier was 32. With the outlier was 35. So it didn't change by a whole lot. So the median changed very little. So we're going to use the median. I did not spell that right. It's supposed to be D, no A. There we go. The median best describes the measure of center of the data. Okay. I want you, on this page, the practice page, I want you to do questions 1 through 7, then check your work with your teacher. If you got any questions at any point, don't hesitate to ask your teacher. Thanks.